Okay, good morning, everyone. We're going to just get started now. Today you're here to talk about how to get started with Kubernetes. My name is Denise Shannon. I'm a program manager here at Rancher Labs. With me today, I have Josh Curl. Josh, do you want to say hi?
Yeah, sure. Hey, everyone.
So today's objectives, we're going to do a technical introduction to Kubernetes using Rancher. We have a couple slides to go through, a couple intro slides, and then when Josh is doing his demo part, he'll be flipping between concept slides and then showing how to actually apply those concepts to Kubernetes. We have demo. There is on the sidebar of the GoToWebinar a little questions part. If you ask questions, there we will either try to answer it through that dialog box, or we will, depending on the question, we might actually, if a bunch of people are asking similar questions, we will answer them live. I will probably interrupt Josh and ask him to explain some stuff more. So just to let you know, basically for this training, we're assuming that you have a basic understanding of Docker. We are going to kind of jump right into how to start using Rancher, or at least not how to really set up Rancher. If you're interested in learning how to do that, we have a Intro to Rancher training in about 2 weeks, so you can go sign up for that if you're interested in that. A couple of resources. We have a doc site. We have a specific Kubernetes section to talk about how to set up Kubernetes, how to configure it. There's a lot of configuration options that I will glance over today, but what those mean in detail will be on our doc site. We have a forums. There are people on our forums that will help you answer questions. Our community is fairly active. If you have questions, go there to get some help. So today's key topics, I'll be doing a demo about setting up Rancher, how to deploy Kubernetes. I can talk about a little bit about setting up kube control, and then I'm going to hand it off to Josh, and he's going to talk about some Kubernetes concepts like pods, deployments, services, config maps, and ingresses. So why Rancher and Kubernetes? So one of the things I love about it is it's like a easy-to-use interface for Kubernetes. So it's a one-click deploy. You'll see it when I go over it. You don't have to worry about all the intricacies of setting up Kubernetes yourself. When a new version is released, we'll verify and certify it against Rancher. We'll make that available, and it's also a kind of a one-click upgrade to be able to upgrade from a previous version of Kubernetes to the latest one that we support. There's upgrade management, like I said, and then if you're interested in, we do have support available as well. I'm going to go, so I already have a box set up that has basically Rancher started. I just did a vanilla plain install of Rancher, and when you first log into the UI, this is what you're going to see. It's going to say, welcome to Rancher. It's going to say, ask you basically if you let us to collect some anonymous information. This actually really helps us as a company to understand, one, who are using which type of environment. So if you're using Kubernetes or Cattle, it allows us to figure out where we should be focusing our efforts. Also, maybe what kind of hosts there are out there, the types of OSs, to see what's the most common to help us to figure out, if there's one that's really popular, then maybe we should add it into our matrix of what we test. So I'm going to actually uncheck it because no one in the company will really care what I'm doing for the training, but for our users, we obviously care a lot. So I have deployed our latest version, which is 1.6.5 of Rancher. When you first come in, you'll see access control is not configured, so I'm going to just turn it on for really quickly for our demo. In the Intro to Rancher training, we kind of cover this a little in more detail, but I'm just going to set up a user for myself. And basically, I'm going to turn on access control now. All of you in the training won't be able to log into my setup and try and do anything with it. Next, what I'll do is I'm going to add an account for Josh so that he can log in when he starts sharing his part. Okay, so now we have 2 accounts in our Rancher setup, one for me, one for Josh. So the next thing I'm going to go cover is environment. So we have currently a default environment, which is going to be a cattle environment. What we want to actually do is add a Kubernetes environment. An environment is usually based off of an environment template, so we have some default versions already available. The one thing I would want everyone to do is, before you actually start launching an environment, you should look at the default templates. You come into here, you can edit the configuration of the default template, and you can see, which version of Kubernetes it's using. So in this release, it's using Kubernetes 1.6.6. You can see if there are other versions available. We usually try and make it so that there's one version of Kubernetes along with a version of Rancher, just because there's typically maybe some changes on our end that need to be released with it, but also the fact that for testing, it's much, the matrices of the combinations, if we allowed all versions of Kubernetes for older versions of our product, would be too big. So usually when a new one is released, so in our next release, we're going to be releasing Kubernetes 1.7.2. That will be available for the next Rancher release. So when you're creating or configuring the Kubernetes template, you can see that all the configuration options are available. So I'll cover them over. There's plain isolation. So right now I'm going to pick none. That's usually what you would want to do for if you're a developer or if you're in development, where basically you can you don't have to isolate where your compute nodes are going to go versus where data or orchestration planes are. So the compute or nodes are where basically your pods are going to be deployed onto which host. Your orchestration, you can isolate to say, this is my single host that I'm going to have that will have all the components that you need for Kubernetes to be running in Rancher. And then you have data nodes, which are hosts where you would put your etcd backups into, and you would want those separated from the other ones. So if you're going to run Kubernetes in production, you would want to actually switch this, go to required. There are actually a bunch of recommendations of requirements that we put that you can find in our docs under Kubernetes, under resiliency planes. So you can read more about what that means and basically also what the recommendation of what your host, the size, and how many for that option. The other option here is a cloud provider. So we use the Rancher cloud provider. We also currently have support for AWS. You would need to select AWS if you wanted to do, I think, persistent volumes within AWS. You would have to pick that cloud provider specifically. There are, as always, more information about your options and what that means to your Kubernetes setup in our docs itself. In Kubernetes 1.6, Kubernetes introduced RBAC, so we have support for that. By default, it's false, but you can enable it. I'm not going to enable it for this demo, but if you want to read about how would that work, how does that apply to Rancher, that is also in our documentation. And then the other ones are a little bit, those are probably the high-level ones I want to cover. There's one if you're going to use a private registry. So I know a lot of people are maybe in an air-gapped setup, or you can only go through a proxy. So if you have a private registry, you want to put what your private registry is here. By default, we have our own Rancher ingress controller. There are some people out there I know who have asked, like, can we use the nginx ingress controller instead? You're more than welcome to do that. You would have to disable our own ingress controller. There are the Kubernetes add-ons that you have to do. I would recommend turning this on. These are things like Dashboard, Helm, SkyDNS that we automatically start and deploy after we launch Kubernetes itself. And then these other ones are much more specific to backups and volume storage, so it's not something that I'm going to cover over today. So here's where you would configure it. You could say configure, and then I would want to save my template so that the changes that I've made for Kubernetes would be now applicable to my default Kubernetes template. After I configure my template, I can start now creating Kubernetes environments based on that template. I would select this Kubernetes environment template. I would want to add Josh as a user. to my environment so that when he logs in, he'll be able to access this environment. I'm going to click on create. Once I click on create, I can go up to this environment selection and switch over to Kubernetes. Here you can see that it's going to say setting up Kubernetes. I don't have any hosts added yet, and so that's why it's going to kind of stay at this page. So I'm going to go to our host page. I'm going to click on add host. So what I've done for this training is I've actually already started 3 hosts. They're actually in AWS. I personally am right now running Rancher OS, but you can use any Linux distribution with Docker on it. I have picked Rancher OS so that I could just easily default to the version that I want for Docker. So right now, Kubernetes only supports Docker up to Docker 1.12.6, and so I have made it so that all my hosts are started there. You can select whatever OS you want. I know that's usually a common question, as long as you install Docker 1.12.6. I will make one quick note about our Kubernetes 1.6.6 template. Right now, if you're going to use RHEL and install and use RHEL Docker, there is a known issue in Kubernetes that we have addressed in Kubernetes 1.7. So if you are going to be using RHEL hosts and using RHEL Docker, then you should wait for Kubernetes 1.7, or you should update your Docker to the upstream Docker version. I'm going to copy this template. Here you can see I just have 3 hosts. All I've done on these hosts is pre-pull all these images that we're going to use for our demo today, just so we won't have to wait for those to come up. Start those up. And then here, close this. You'll be able to see that those 3 hosts are now registering into our setup. They are starting to deploy our Kubernetes stacks as well as our infrastructure stacks. So besides our Kubernetes stacks, we have a couple of infrastructure stacks that are required for just getting networking and Rancher-related infrastructure set up. So like for networking, so you could create our overlay networking so your containers can talk to each other. IPsec goes along with networking. Health checks, so we have some health checks on our Kubernetes services that are part of the Kubernetes orchestration stack. So if a host goes down, you know that those containers will be able to be rescheduled onto another host. So you know your Kubernetes stack will always be up and available. We're gonna wait a little bit here while we wait this to get up. I did invite you to the environment. Okay. So that is at least most of what I'm going to cover. I usually like to wait until at least the Kubernetes stack is up and dashboard is working before I hand it off to Josh. So I guess, are there any questions right now? Do you see?
I haven't answered yet.
Okay, cool. So yeah, we can see, let's see. See, 2 of my hosts appear to be struggling to register, which is a bit strange. So I'm gonna go and see which hosts those are. Later ones. Seem to be coming up. Oh, that one's coming up. That one has some containers on it. So I'm just checking to see what's going on. Maybe it looks like, oh, there they are. So it looks like those, there are a bunch of other containers besides our Rancher agent container that was spinning up. So now they're all my hosts are active. It's going to just take a little bit for everything to get up and running and settle. You can see here now, even now that Kubernetes is up and active, you can see that I have access to my dashboard and CLI. I'm going to cover a CLI over real quick, where basically you can use kubectl. You can either generate a config here that you would be able to use in your local host. So that's what Josh will be doing so that he can start using kubectl on his laptop when he gets going. Otherwise, you can just use kube control in the web shell yourself, so I can see what nodes we have, see how it's going, check on my stacks. Looks like initializing is just a state that of where Rancher is just confirming that the health checks are all running correctly and everything can talk to each other. Usually the containers are already up, they're just confirming that. I'm going to see, so our dashboard is probably not currently available because it probably hasn't started yet. Do I look for them? I always forget.
Pod-n cube system.
Yeah, pod-n cube system, right?
Yep.
Okay, you can see that they are up and trying to get started. So all of the pods are currently, they're in the cube system. Not look very happy on the back end. I just took a look from Josh's screen. You can see that they're trying to get up and going. So let's see. Oh, looks like we're just waiting for the last cube DNS to get up and running. So yeah, if you find that your dashboard is not available, you can always go to the web shell to see kind of what the status is, kind of what I did, where you can look for the pods that are in the namespace cube system to see what the status of them. Once those pods are up and running, basically Rancher's up and go, or Kubernetes is up and running. You can see that our dashboard is available. There's nothing there because we haven't deployed anything. And then I'll just let everyone see that, in our infrastructure stacks, you can see everything is active and up and available. On our hosts, you'll see a combination of stacks. I'm going to hide our system stacks, so that's like our Kubernetes orchestration stacks, and really the remaining ones that will show are going to be anything that's been deployed in Kubernetes itself. Okay. At this point, I'm going to hand it off to Josh to make him the presenter so that he can start showing you guys some other stuff. I can see your screen.
Okay, so for the remainder of the talk, I'm just going to be discussing purely upstream Kubernetes concepts and how you'd actually start using Kubernetes once you have a cluster up and running. So like all the concepts past this point will apply to any Kubernetes cluster, even outside of Rancher. So the first concept I'm going to discuss is that of a pod. So this is, it's the smallest unit you can actually deploy to Kubernetes. So a lot of people, when they start running Kubernetes, they're a little bit confused why they can't just go and launch containers. So instead of like just the old launch containers, Kubernetes is a different abstraction. This is kind of like the most fundamental unit. So pods are one or more containers that are always scheduled to the same host. So at the networking level, each pod is given a unique IP address. And so for within Rancher, this IP address is going to be on the Rancher overlay IPsec network. So when pods communicate to each other, they're going to be communicating over this network and having encrypted traffic. So the containers are also within the same network namespace, which means when they communicate within the pod, they can actually talk to each other over local hosts. And this also means that they're sharing the same IP address. So if you were to go and launch two Nginx containers within a pod, you would see that they're conflicting because they're both trying to bind on the same port within the IP address of the pod. So other than this, the idea of pods is a little bit confusing to new users of Kubernetes. So for the remainder of this talk, just try to think of pods as an individual container. So for most use cases, like that's actually all you need. It's more of an advanced concept that's just kind of there when you need it. And as you use Kubernetes more and more, you'll start to see the more the value of it. All right, so now I'm going to go back and generate the config necessary for my kube control client to talk to this cluster. So for those of you using Kubernetes, you'll probably get very familiar with kube control as it's the main CLI to use for it. so now on my laptop, I should be able to do kube control like git node or some other command just to see that it's actually working. And we can see that it's working. Okay, so the first thing I want to do is show off a few Kubernetes manifest files. So these are just YAML files that contain various configurations. So in this case, what we're going to be doing is launching a new pod. So if we look at this file, we can see that there's a lot of things that are just common values you'll see in all the Kubernetes resource files. So in this case, we're going to see a version, which for pod is just v1. We're going to see the kind, which in this case is pod. And then every other resource, you're also going to see metadata, such as name. So in this case, we're going to use the name shell. And then under spec, this actually contains the definition of what's going to be contained in the pod. So you can see that under containers, there's actually a list, so you can have more than one container here. In this case, we're just going to launch one called shell. And we're going to use an image called Josh wget shell, which just has some various tools in here that we'll use for the remainder of the talk just to show off some features. The command here is just sleep infinity. So I'm going to launch this pod, and it's just going to kind of sit there. And then later on, I'm going to exec into it so we can show off some commands in there. So to launch this pod, I'm going to use the kube control create command, which is just going to tell the Kubernetes, hey, I have this resource. I want you to create this. So you can see that the shell is created, and then we can use the kube control get commands to see which pods are actually there. Okay, so you can see that it's already running. And now that it's running, I'm going to do kube control exec to start a shell within it. So for those of you familiar with the Docker CLI, kube control exec works pretty similar to Docker exec, other than the fact that the actual pod itself is not going to be running on the same host as where your client is. Okay, so now we have a shell inside of here. This shell here is actually running within the context of the pod. So I'm going to do one more thing before I can show off what I was going to show off. So I also have another pod here called Nginx pod, and it's pretty similar to the last one. There's not very much configuration here, but instead of launching a custom image, we're just going to launch the upstream Docker Nginx image and then expose this on port 80. So I'm going to do kube control create again to create this pod. Okay, and if we do kube control get pods again, we should be able to see both of these running. So now I'm going to show off another command called kube control describe. So if I do kube control describe pod and Nginx, I should see a lot of different information about it. In this case, I'm just going to look around and I'm going to grab the IP address of the pod. So if I were to exec into the Nginx pod and then do IP address show, you'll actually see that's the same IP address as what we just got using kube control describe. So now I'm going to go back to my shell container. And I'm just going to do a curl of this IP address. So you can see that we actually hit the Nginx pod, and then we're just printing this out to the screen. And so other than this, I have one more manifest file that I want to show off for pods, just to show that there's like more configuration available here. So the previous two were just pretty simple ones that just have like an image and a port. So for this one, I just want to show there's other things you can do, like add environment variables, bind mount directories from the hosts. You can also control scheduling here and say, like, I want these pods to only run on hosts with these labels. Or do other things like make it run in the host network namespace, or maybe add privilege true so that the containers inside of it are privileged.
Would you want to maybe, in your web browser, instead of showing the CLI, maybe you can show the hosts so they can see when they come up, and then uncheck show system. Yeah, so we can see that the two containers that we ran here, or two pods we ran here, the Nginx one got scheduled to the first host, and the shell got scheduled to the third host. So when I did a curl on that one, we're actually going and using cross-host communication. Okay, so the next concept I'm going to describe is that deployments. So typically when you're actually using Kubernetes, you're not going to go and deploy pods by themselves. And that's just because the lifecycle of pods is not actually managed. So when you use a deployment, you can define the desired state of a group of pods. So you can say, I would like to have three instances of this pod here. And the deployment is responsible for making sure that your cluster actually achieves that desired state.
All right, so now I'm just going to do a couple examples of deploying to Kubernetes using deployment. So the first one I'm going to launch is very similar to the pod that I just launched earlier, but in this case, we're going to be launching it via deployment rather than launching as a pod directly. So in this case, like I said earlier, all Kubernetes resources have these same common fields, but this time we're going to be doing kind deployment. And then under the spec field, this is describing the desired state. So in this case, we're saying that we want 3 instances of this pod. And then under template here, this is actually the same configuration as it would be for a pod in a separate resource file. So the only thing different here is that we're specifying a particular version of Nginx. So in this case, we're running 1.13. And then we're also going to be adding a particular label to all the pods that are deployed via this deployment. So we're going to come back to that later to show why that's actually useful. But just know that each pod that's launched by this deployment is going to be given the label app Nginx. So now if I do kubectl creates on this deployment, and if you do kubectl get pods, we'll start to see Kubernetes actually bringing up all the instances of this pod created by the deployment. So you can see that there's a unique label attached to the end of the Nginx. So this is just done so that you can have non-unique names. Okay, so just to show what the value of a deployment is, I'm going to delete one of these pods, and then we should see that the deployment is responsible for creating a third one again. And if we do kubectl get pod again, we can see that it's brought up. And so on the left, you can also see on the host view that all of these pods are being created as well. And this will show you which hosts are on, a little bit more information there for the Rancher UI. Okay, so next I'm going to use the kubectl scale command. So this just edits the desired state of just the number of replicas for the pod. So in this case, I'm going to do kubectl scale deployment Nginx and set the number of replicas to 2. And then if we do kubectl get pod again, we'll see that there's one pod here that's terminating. And if I do it again, it's probably, okay, it's just taking a little bit to stop the pod. Okay. So yeah, now we only have 2 Nginx pods running. So that is one way to update an existing deployment. One other way is using the kubectl edit command. So if we do kubectl edit deployment Nginx, then we'll see here we're actually looking at the internal representation of this deployment within Kubernetes. So almost all fields within here are actually editable. So if we go back to replicas and we change this to 3 again, and then we exit, we'll see that Kubernetes updated the deployment, and then we'll have another pod running again, or a third pod running. So the next command I'm going to discuss is the kubectl apply command. So up until this point, whenever we're creating a resource, we've been using the kubectl create command. Another useful one is the apply, just because you're not always creating a new resource. If you have an existing one and you'd like to update it, kubectl apply is pretty useful for that. So let's say, for example, we wanted to roll back to an earlier version of Nginx. So I'm going to switch this to 1.12 instead of 1.13. We can do kubectl apply -f Nginx deployment. And then we should see that all of the pods within this deployment are going to slowly be deleted and then recreated with new ones with a newer version of the image. So in this case, kubectl apply is updating an existing deployment. But if you were to use it on one that wasn't already created, it would just create it just like kubectl create did. So you can think of it as create if it doesn't exist or update the existing one. So for the rest of the talk, I'll probably use kubectl apply just because it offers a superset of functionality of kubectl create.
I'm going to interrupt you real quick. Someone had a question, and I don't know the answer, so I don't know. But basically, someone asked, can you easily run cron jobs, or do you need to create a container in a pod that runs cron?
There is a concept in Kubernetes called jobs, so I wouldn't recommend doing just manually launching pods. I would look into the job concept. So I'm not going to discuss it in this tutorial, but the docs on this are actually pretty good. If you can.
I'll go look for it and see if I can find it for him.
Okay. Okay, so we can see that this was configured. So what I'm going to do is kubectl get pod again. So we still see that there are 3 here. These are actually 3 different pods from earlier. So just to prove that, I'm going to use the kubectl get pod command. But this time I'm going to use the -o flag. which will show you the existing representation of this in the Kubernetes cluster and then print it out. So we can see if we scroll up that the image here is actually 1.12. So all these Nginx pods did get correctly rolled back. Okay, the last command I'm going to show is the kubectl run command. So this is just a pretty useful command for development or when you just want to launch a one-off deployment without having a resource file. So if we do kubectl run, let's say nginx2, and just set the image to nginx again, we'll see that Kubernetes actually goes and creates a deployment for us. So if we do kubectl get deployments, we'll see that the nginx2 deployment was created. And so the kubectl run command isn't really anything special compared to like apply or create. All the kubectl client is doing is just creating one of those resources behind the scenes. So we can still do kubectl gets deployments with the -o flag, and we'll see that we can still see there's a resource behind the scenes that is actually created for it, even when using the kubectl run command. Okay, the next concept I'm going to discuss is, sorry, actually before I get to services, let me just say for those of you who are reading like other Kubernetes tutorials or who are watching older ones, you'll often see these two terms here, so replication controller and replica set. Generally, for newer Kubernetes clusters, you don't have to worry about these concepts. So before the deployment existed, replication controller was really the only one around. But they're slowly being superseded by the functionality of deployment. So in general, unless you see a need for it, these two concepts are replaced by deployments. Okay, so now I'm going to discuss the concepts of services, which define a DNS entry that you can use to refer to a group of existing pods. So in the previous case, we saw that the deployment was going out there and creating a bunch of pods for Nginx. The problem with that is if you have other services in your cluster that want to talk to Nginx, for example, they would have to know the pod or the IP addresses of the pods. And those IP addresses are also ephemeral too. If for some reason, a host goes down and then the pod gets deleted, the next pod that would be brought up by the deployment might have a completely different IP address. So to fix this problem, you can use Kubernetes services, which provide a consistent endpoint for a group of pods. And you can kind of think of these as load balancers. So you're going to be given an IP address from the service, which then proxies traffic to other pods behind it. All right. And similar to before this, I'm just going to launch a few Kubernetes resources that creates services behind the scenes. So the first one I'm going to launch is just a pretty simple service that makes use of the deployment that we launched earlier. So if you remember, I was saying that there's a label called app nginx on each of those pods that are being launched by the deployment. We can see here that for the service, we're using selector app nginx, which means the traffic for the service is going to be routed to any pod that has this label. And then the deployment is responsible for making sure that every pod has this label on it. And so for ports, we're going to be going from port 8080 to 80, and then port 80 to 80. I'm going to do kubectl apply to create this service. And then just to check that it was created, let's do kubectl get service. And then we can see the default one that comes built in with Kubernetes here, and then the one that we just launched. So if I exec back into my shell container, we should be able to do curl nginx.defaults.svc.cluster.local. And this is just the format of the DNS that Kubernetes uses. So the service name is what goes first here. Sorry, I think I have a typo somewhere. Okay, that's working.
Why don't you explain what you're trying to debug?
Yeah, so when I do a curl on this URL here, the DNS resolution should return the cluster IP of this service, and then that should route traffic to the underlying pod. So if I do a curl on the IP itself, it works. It looks like Kubernetes DNS is not resolving this. Is there like an obvious typo here then?
No, I think it looks like you've checked it incorrectly.
Oh, maybe the DNS just didn't have it wasn't updated yet. Okay, so it's working now. So when I do a curl on this, the traffic is reaching one of the pods behind this service and then returning it to me. But we don't actually know like which particular pod the traffic is being routed to. And if I were to launch another service and then curl the same DNS, it could actually be a completely different pod handling the traffic. So when I launched the service, I also had the 8080 port exposed as well. So I can also do 8080, and then it would also route traffic to the underlying Nginx pod, which is still listing on 80. Okay. The next topic I'm going to discuss is that of config maps. So these are kind of a way of storing simple and not very large configuration files within Kubernetes. And then when you launch pods, you can refer to these existing config maps and then expose them in the pods in two different ways. So you can expose them as environment variables, or you can expose them as local storage within the pod itself. Okay. So I have a Kubernetes resource file here that describes a config map. So we can see the kind here is config map, and then we're going to have two different keys within it. So we're going to have key 1, which is value 1, and key 2, which is value 2. And then to create this, I'm going to do kubectl apply. And then let's just check that it was created. Cool. So we can see that it was created here. And then let's just do a kubectl get on it to see the actual values stored by Kubernetes. Okay, so you can see that like internally, Kubernetes was actually now responsible for storing this data, and then behind the scenes, this data is actually stored within etcd. So now that we have this config map created, I'm going to expose this in two different ways. So the first one I'm going to show off is exposing it as an environment variable. So in this case, we're going to launch a pod. It's just going to be a pretty simple Ubuntu container that sleeps forever. Because after this, I'm going to go back in and exec into it. And then for the environment command, I'm going to expose the environment variable primary key, and I'm going to reference the config map we created called testcm, and I'm going to say that we want to set this environment variable equal to the value of key 1. And then similarly for secondary key, it's going to be equal to the value of key 2. So let's do kubectl apply on this pod. And then let's exec into this pod. Oh, I think it's still starting up. Let's give it a second. Okay, there we go. All right, so now if I do the env command just to show what environment variables are available, we're going to see primary key equal to value 1 and secondary key equal to value 2. And similarly, you can also expose those same variables as local storage within the pod. So if we do kubectl, or actually, let me look at the manifest file first. Okay, so in this case, instead of setting environment variables, we're going to create a new volume by referencing this existing configuration map, and then we're going to expose this in the path etc config. All right, and let's exec into this pod here.
Someone asked, why does this pod container get the Nginx information as environment variable?
Like, I'm not sure if the question is what would be the purpose of it, or why does this particular case does it get it? So it gets it because we set it here in the configuration file. It's set to read from this configuration map, and then Kubernetes will actually read from this config map before it launches the pod, and it will set these two environment variables. The motivation here, if it's not clear yet, I have like a more real-world example coming up after this.
So I guess if you still have another question, feel free to ask it again or ask for more clarification. But I think it's more right now. Josh is demoing like how do environment variables, kind of how you would set it up in your setup and how you could use it, and then I think he'll do another further example of what you actually might want to use it for versus this like simple example.
Right. Yeah, this is a pretty contrived example here. All right, so let's look at the volume pod that we just launched. If we navigate to the directory we specified in the manifest file, we can see that there are two different files in here, and these will each contain the corresponding value from the config map. So we have key 1 and key 2. Okay, so now for a better example here, that kind of wraps up like the last couple of things we were discussing. So before I get to this, let me just briefly show the page for the upstream Nginx Docker image. So if you see here, like the way they recommend if you're just using Docker to control the configuration file for it, is they just bind mount in a file from the host. So there's no way to actually put in your own image or your own configuration file into the upstream Docker image without doing it this way. But when you're using Kubernetes, you can use a config map instead of doing this bind mount, since when you're using a cluster, a Kubernetes cluster, you're not actually sure which host the pod is going to land on. So there's no way to make sure that Nginx configuration file is already on the host without using some other out-of-band process. So here, I have an existing Nginx configuration file. And so the contents here don't really matter too much. This is just for demonstrating how I might use a config map. But what it's going to do is route traffic from port 80 to rancher.com. So it's going to act as a proxy here. So what I'm going to do is create a config map by referencing this file. So as I showed earlier, you can create a config map by creating a Kubernetes resource, but you can also use the kubectl create command just to create a config map directly from a file itself. So I'm going to call this proxy cm, and then I'm going to use the from file command or flag. I think I have a typo here somewhere, so I'm just going to copy my existing one. Okay, so you can see that Kubernetes actually read this local file and then created a config map based off of it. So let's do kubectl get config map just to show that it's actually being stored. So you can see that there's a config map here with one key called default.conf, and then the contents is just the file that we had seen earlier. So now we have this config map created. I'm going to use it within a deployment. So in this case, I'm going to run 2 replicas of an Nginx container that's exposed on port 80, and then I'm going to expose this file that we just created under the directory etc nginx.conf.d. So this is just the directory that Nginx is set to read to by default. So I'm going to do kubectl apply on this deployment. And then to expose this deployment to other pieces of the cluster, I'm also going to expose it as a service. So here we have proxy service, which just routes traffic from 80 to 80 on the proxy selector label. So I'm going to do kubectl apply on this now. Okay, so now that everything in here is created, I'm going to go back into my exec shell. And then I should be able to do curl proxy dot default dot svc dot cluster dot local. And you can see that this is actually the contents of rancher.com. So what happened here was DNS resolved this service, this name into the IP address of the service, which then routed traffic to one of the pods behind the scenes, which are running an Nginx container proxying traffic from rancher.com. So the last thing I'm going to discuss is that of an ingress. So everything we've done so far just concerns traffic between different pods within the cluster. So then once you have all these services running, you might want to expose some of these services to the outside world, and this is where you use an ingress. So an ingress allows you to define how you want the traffic to be routed to the outside world based on factors like host name and path. We go back here, I'm going to expose 2 of the deployments that we had launched previously. So So in this file, I have actually two different Kubernetes resource files. So when I use the triple slash here, it's just saying that there's two different resources here. And then when I do kube control apply in this, these are both going to get created independently. So I could have had two different files, each one with one of these resources, but in this case, I'm just going to do it all in one big file.
Do you want to maybe change that screen back to the Rancher screen?
Okay. So the first ingress resource is going to bind to port 9000, and then it's going to route traffic to the proxy service on port 80. And the next one's going to bind to port 9001 and route traffic to the Nginx service on port 80. So let's do kube control apply on this. All right, and then we can see that the ingress created two, or Kubernetes created two different ingresses here. And then if we look at within Rancher, we can see that behind the scenes, what Rancher is doing is actually spinning up load balancers in response to these two ingresses being created. So if we do kube control get ingress, we'll see that there's two different ingresses here, and they're both running on the same host within this cluster. So Rancher actually spins up this load balancer and then binds the port to the host IP here. So for Nginx, if we take this address, we put it in our browser, and we bind it to port 9000. Oh, yeah, mix those two up. This is actually Rancher. But this is the proxy one here then. And this one should hopefully be Rancher. There you go. Okay, so I think I just mixed up the two of my configuration files. But yeah, these two services are now exposed to the outside world. So I guess like the last thing I'll briefly mention is a lot of people see the concept of a load balancer service within Kubernetes, and they wonder how that differs from an ingress resource. So ingresses allow you to do a lot of different powerful rules based on like routing and routing like based on host name and path. So you can have one ingress that routes traffic to multiple different services within your cluster. So just having those different configuration files or configuration available means that ingress can kind of do more than what the service load balancer does. And then when you use a service load balancer, the idea there is that you have this service within your cluster, and you basically just want to expose some public IP to the outside world. There's not really much more configuration available beyond that. And typically, when you use a service load balancer, it's going to be brought up by your underlying cloud provider. So, for example, if you're running on the AWS and you're using Rancher with the AWS cloud provider, and you create a service type load balancer, it's actually going to spin up an ELB that's responsible for routing traffic into your cluster. Other than that, the ingress resource can also be controlled by other various controllers. So in the case of Rancher, the default is that it spins up an HA proxy-based load balancer. But if you want to, you can actually disable that functionality and then install other ones like the Nginx ingress controller, which just switches it out to say that each load balancer brought up for ingress resources are of type or use Nginx instead of HA proxy. So I think that's the end of my content. If there are any other questions or anything, we can stick around and answer those.
Do you want to just flip back? Yeah. Oh, so someone asked, so you could use, I never mind, traffic as an ingress?
I think there is a traffic ingress controller available. It doesn't seem to be nearly as popular as HA proxy and Nginx. I think there is one out there though.
In order to use any other ingress controller out in Kubernetes, you would need to configure your deployment in Rancher to disable our internal ingress controller. So just a couple things before we wrap up. So one of them is that we do have a user Slack. Here's the link to be able to go there. There is a Kubernetes channel. It's pretty active with our community as well as in Rancher employees. So please join there. And then I guess we just want to say thank you. We'll stick around to see if there are any more questions, but it does look like we don't have that many questions today. So yeah, you can try and find us online if you need anything. Thank you so much for joining. And then, as I said, there is another Rancher training to just learn about how to set up Rancher itself that occurs in 2 weeks, and then usually in about a month from now, there's usually a monthly Kubernetes training that will cover over the same concepts. So there, okay. Someone asked, would you run Rancher in a public or private network? That is really up to you. That is your choice. We have people running it in all types of networks, so whatever you would want to do. Someone asked, is there a specific config in YAML or something in order to configure the ingress to multiple services?
There are specific different fields you could put within an ingress resource to do those kind of things. If you look at the Rancher documentation for our ingress controller, you'll see a lot of those different fields. And we have examples for most of those.
I will send over the link in terms of what, for ingress, there's a lot of options out there, and there's a lot of annotations, at least for the Rancher ingress controller that we support ourselves, that you can go look at. Sorry.
So this question is, if you're using the Rancher load balancer that's spinning up HA proxy resource or HA proxy load balancers, does it bind to unique public IPs per HA proxy server? The question, or the answer to that is depending on how you schedule the load balancers. So if you look at our documentation, you can see that you can actually bind the load balancers to particular hosts within your environment. So if two ingress load balancers land on the same host, they will bind to the same IP. But if you had two hosts available and you controlled scheduling in such a way that you had two different load balancers binding to two different IPs, it would be different. Most of the scheduling around ingress is basically up to the user.
Okay, the questions have kind of stopped. I am going to at least stop the audio. We'll stick around for a couple of minutes on the actual GoToWebinar to see if there are any more, and we'll just answer them directly there. Otherwise, thank you so much for coming today, and hopefully you'll be able to get up and running with Rancher and Kubernetes. Thanks, everyone.